This is going to start a unique idea that maybe you've never seen before. Perhaps the first thing we've done so far that's totally new to you. We're going to take a look at complex numbers. And the concept is this. So I'm sure somewhere in your days you've seen this issue, that if I have a negative underneath a square root, it can't be done because there's no two numbers in the universe that can create negative 9. So it's got to be two of the same number. Well, there's no way to do it. 3 times 3 is 9, negative 3 times negative 3 is negative 9. So we've always said this doesn't exist. But mathematicians looked at this for quite some time and began to find that you could continue the math process if you just made one simple little change. So if you thought of this, so we can now bring the 9 out. Basically what I'm saying is complex numbers, imaginary numbers is the root of it. We have created an idea called the square root of negative 1. And what we're going to call this is I for imaginary. Now, there's some debate. I've heard some things that perhaps this actually can exist in the real world, but there's an entire realm of mathematics that can continue to work if you just sub the idea that the square root of negative 1 is an actual number. But we're going to call it an imaginary number because it doesn't happen supposedly in the real world. Now, this I is just a shorthand for it. It just is always going to represent the square root of negative 1. So every time we see I, this is what it means, but it just becomes more convenient to write this simple little I than to write the square root of negative 1 over and over again. Okay, so that's an imaginary number anytime we have the square root of negative 1. Now, we can put that together, say, with a real number. So we can create a complex number. This has a real part, the 3, and then this has the imaginary part, 4i. And so that 4i would just be the 4 times the square root of negative 1. That's what that would mean. So this imaginary part and this real part can come together to create something called a complex number. Oh, they literally chose the one I did. Okay, so I didn't know they were going to do this, but the square root of negative 9, we can think of that as the square root of 9 times the square root of negative 1, which is actually literally the one I was choosing. Now I can do this part. I get 3, but this has to be called I. So we have 3i. So because this is multiplied together, this is an imaginary number. Yeah, so if we wrote it in complex form here, we have nothing for the real part, and the 3i is the imaginary part. Okay, so let's do this again. So I'm going to just break down 24. Well, this is what we've got going on inside there, these two things. But now, do you remember how to break down a number that doesn't have a perfect square root? What we're going to do is it takes a pair of 2's to come outside. So I broke down 24 into its pieces, and I can bring out a single 2. It leaves a 6 behind. So I've got 2 square root of 6, and then this imaginary part is just going to turn into I. So I've done it as if it was the square root of 24 and the square root of negative 1, and I've created this. So I simplified the square root of 24 the best I could. The square root of negative 1, it's the same thing, but we've just changed it into that abbreviated form, the I. All right, now you can graph these as well. So they'll call it the complex plane. Instead of our normal plane, where we have x and y are values in the real world, what we're going to have now is the x is going to be the real portion, and the y is going to be the complex portion. So let me show you what I mean. So if I have the complex number negative 2 plus 3i, what we're going to do is the x is going to work the same, but it's going to refer to the real number portion. So I'm going to go to negative 2, and then I have 3 in the imaginary. Well, the y is now going to be the imaginary. So I'm going to go up 3. So back to up 3. So what do they have it for us? Okay, so we're doing another one here. So in the real portion, which is the x-axis, we're going to 3. In the imaginary portion, which is the I part, we're going to go down 4. So again, this is the complex plane. It is not the same Cartesian plane that we're used to working with. 3 is the real number, negative 4 is the imaginary. We can do this again here. So 1, 2, 3, 4. This is the x is the real portion, so negative 4. And then what's in front of there would be a negative 1. So negative 4, negative 1 be right there. Okay, now adding and subtracting, so multiplying and division are coming in the next two videos. That's a little bit more complex, but this is actually pretty straightforward. What we're going to do, it's like combining like terms. We're going to put together the real number portion, and we're going to put together the complex number portion. Let me see how they did it here. So yeah, this is good. Okay, so we're putting together these two complex numbers. Well, the real number portion can be put together, and the complex portion can be put together. And it really is that simple. So it is essentially combining like terms. You're just combining real things, which can go together, and complex things. So we do it again here, and the negative 5 and negative, oh, we're subtracting this time, so be careful. Same as it always is. This is going to change the signs of everyone who follows. So they turn this into a positive 11 and a negative 2i. Now the like terms can go together, and the imaginary parts can go together. And I get 6 plus 5i. Okay, now they're getting tricky with us here. Subtract this number from 3 minus 4i. Now be careful. That just means if you're taking a number from, we're going to, so it reads left to right like this, but we're going to flip it around. This is what it means to subtract something from. Okay, now the first thing I'm going to do is I'm just going to go ahead and make sure I don't forget to change the sign of everybody that follows. So let's put together the real parts. 3 and negative 2 is 1. Negative 4i and negative 5i would be negative 9i. Okay, again, there's probably not enough examples. I'd like there to be more, so I can do supplementary videos, but hopefully that makes sense. The adding and subtracting is pretty straightforward. Combine the like terms. Real parts go together. Imaginary parts go together. Just watch out for negatives, because it's going to change the sign of everything that follows.